Honey has been valued for thousands of years as both a food and a natural remedy. Ancient civilizations in Egypt, Greece, India, and China used it to preserve food, soothe sore throats, and treat wounds long before its science was understood. Modern research confirms honey has strong antibacterial properties, but these come from multiple factors working together rather than a single natural medicine effect. Not all honey is equally effective, and its ability to inhibit bacteria depends on how bees produce it and its unique chemistry. So, what exactly makes honey such an unfriendly place for bacteria? The answer begins long before honey reaches the jar sitting on your kitchen shelf. Let's dive in, right here, on History of Simple Things. One of honey's greatest defenses is something called low water activity. While honey contains around 17 to 20% water, most of that water is tightly bound to its concentrated sugars, making very little of it available for bacteria to use. Microorganisms need accessible water to grow, reproduce, and carry out essential life processes. In honey, they simply cannot obtain enough moisture to survive. This creates a harsh environment where most bacteria either become inactive or die altogether. The extremely high concentration of glucose and fructose also creates strong osmotic pressure. When bacteria come into contact with honey, water is drawn out of their cells through osmosis, causing them to shrink and lose their ability to function. This same process also explains why honey rarely spoils, even without refrigeration. While certain bacterial spores can survive in dormant form, they cannot actively multiply inside honey. This unique balance of low available water and concentrated sugars forms the first layer of honey's impressive antibacterial protection. Another reason honey naturally fights bacteria is its acidity. Most honey has a pH between about 3.2 and 4.5, making it more acidic than many bacteria can comfortably tolerate. This acidity comes primarily from gluconic acid, which forms when enzymes added by honeybees convert glucose into other compounds during the honey-making process. Many disease-causing bacteria grow best in environments that are close to neutral pH, around 6.5 to 7.5. Honey's acidic conditions interfere with bacterial enzymes, damage cell membranes, and make it much harder for microbes to reproduce. Although acidity alone does not kill every type of microorganism, it works together with honey's low water activity to create multiple barriers against bacterial growth. This layered protection is important because bacteria that might tolerate one unfavorable condition often struggle when several challenges occur at once. Instead of relying on a single antibacterial ingredient, honey combines different natural defenses that reinforce each other, making it far more effective than any one factor alone. One of honey's most interesting antibacterial features comes from honeybees themselves. While turning nectar into honey, bees add an enzyme called glucose oxidase. In the hive, this enzyme stays mostly inactive because honey contains very little free water. But when honey is diluted, such as on a moist wound, the enzyme becomes active and converts glucose into gluconic acid and small amounts of hydrogen peroxide. Hydrogen peroxide is a natural disinfectant that helps damage bacterial cells by producing reactive oxygen molecules. Although the amount produced is far lower than in commercial antiseptics, it is released slowly and steadily. This gentle, continuous action helps suppress bacterial growth without heavily irritating healthy tissue. Because of this slow-release antibacterial effect, honey is especially useful in medical-grade wound care, where it can support healing while reducing infection risk. The flowers visited by honeybees provide more than nectar. They supply polyphenols and flavonoids, plant compounds with antimicrobial and antioxidant effects. Their levels vary with floral source, giving each honey a unique chemical profile. Some varieties contain higher concentrations, resulting in stronger antibacterial activity. Manuka honey from New Zealand is a well-known example, rich in methylglyoxal, which remains active even when hydrogen peroxide effects are reduced. Research shows these plant compounds can weaken bacterial cell walls, disrupt energy production, and inhibit biofilm formation. Biofilms normally protect bacteria by forming resistant colonies that are hard to treat. By breaking down these defenses, honey's plant-derived chemicals add an additional layer to its already complex antibacterial system. One reason honey continues to interest scientists is that bacteria struggle to develop resistance to it. Unlike many antibiotics that target a single bacterial function such as cell wall formation or protein synthesis, honey works through multiple mechanisms. These include low water activity, acidity, hydrogen peroxide production, osmotic pressure, and plant-derived compounds. Because these defenses act together, bacteria would need several simultaneous adaptations to survive, making resistance extremely unlikely. Researchers are studying honey as a complementary option for chronic wounds involving antibiotic-resistant bacteria. However, experts stress it should not replace prescribed antibiotics for serious infections unless advised by a medical professional. Its strength lies in natural multi-layered defense system evolved. Honey's antibacterial power comes from several natural defenses working together. Low water activity and high sugar content that draw moisture from bacteria, acidity, B enzymes that produce hydrogen peroxide when diluted, and plant compounds that vary by floral source. Together, these make honey a powerful natural preservative used in medicine, food preservation, and research. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.